All right, so server-side technologies. Like I say, this is the part of this course that gets confusing. There are so many different technologies used on web servers. At first, it seems overwhelming. After a while, you get used to it. So you can often get a banner by just connecting. Nmap has a -SV switch to harvest banners, and they'll get some kind of banner telling you what version of things are being used here at Apache, with this version of OpenSSL, this version of PHP, and so on. It's a good idea, by the way, to block messages that tell this to every user, because they really don't need to know, and it might help them find a vulnerability. But anyway, most products do have banners available. And you can do HTTP fingerprinting. There's a tool called HTTP Recon that will try to identify versions using subtle clues. As I mentioned, Nmap will try to do it, and there's also Wapalizer. This one's quite popular. It's a browser plugin that will tell you all the technologies in use on a page. So it's using Apache, it's using PHP, this version, and so on. It will just analyze a page looking for clues in the source code and everywhere it can find it. And file extension will typically tell you a lot. ASP is Microsoft Active Server Pages, JSP is Java, PHP, of course, is the classic open source thing used by small companies and people who want free products. The LAMP server, Linux, Apache, MySQL, and PHP, that's what I use. There's Perl, Microsoft DIL files, and so on. There's just a lot of different things, and the file extension will tell you. And of course, you can use a search engine to tell you what a file extension means. And error messages often give you far too much information. Like this is a custom ASP error message. At one time, I was checking a lot of public websites for vulnerabilities, and I checked the Democratic website and didn't find much. I went to the Republican website, I put an apostrophe in the URL, and got a whole page of screaming red source code. And I said, I think I'll quit messing around here. These guys will probably get mad at me, but I think it's better now. But at that time, it was pretty sloppily made. Anyway, here's a generic. You want to go to a unrecognized file extension ASPXX, and you get a generic message here, and generic 404. This is considered poor web design. To let you get a message like this, you should have a custom 404 page that you control, that looks pretty, that still has your branding on it. All right. And so different libraries may lead to different error messages. So you'll find that here, the file extension mappings in IIS 5.0. There are different rules to handle different libraries that may be called. And there's something called open text that lets you have these commas in the URL, referring to the content management platform. And like I said, most web pages are not primitive and simple like mine anymore. They are mostly using content management like WordPress and Drupal and such. So directory names will give you clues like servlet on Java, PLS on Oracle servers, Ruby on Rails is Rails. I haven't seen much of that. That was all the rage like 6 or 10 years ago. I haven't heard much Ruby on Rails these days. Anyway, and the session tokens that you'll see if you look at the headers in Burp and look at your tokens, they're often pretty obvious. Java has JSession ID, Microsoft has ASP session ID, PHP has PHP session ID. They're not trying to hide it. It's pretty easy to tell what technology is being used. And third-party components like shopping carts, logins, message boards. These often contain known vulnerabilities. One of the most common things is WordPress sites that use common third-party add-ons, and a lot of those add-ons are dangerous and vulnerable. That's why the same thing is true, by the way, of browser extensions. A lot of people casually put in Chrome or Firefox extensions in their browser without realizing that you're trusting the people who wrote those extensions, and often they are sloppily written and are out of date. And another fun fact is if you write a browser extension that gets pretty popular, criminals will contact you and offer you money to buy the rights to the extension, and people sell it to criminals who then put malware in it. So a lot of browser extensions that have been known for years and trusted suddenly turn evil on you. And your average end user doesn't understand that they're giving every extension the right to mess with your web pages. And the same thing's true of your web server. All your WordPress extensions have the right to mess with your website. And so here's the steps. You identify all the points where user input goes in, look at the query string and any other channels that feed third-party data into the app, look at the banner returned by the app to get a clue what kind of servers are used, and look for other software identifiers and use tools to find out what you've got, and then look to see if those versions are vulnerable, and then look at the map of URLs to find other clues about what's going on. HTTP print is a tool they recommend but this hasn't been updated. There's alternatives. Nmap, Netcraft, and Shodan and Wappalyzer are more modern ways to list the technology in use on a site. And so look at the session tokens, use list of common technologies, unusual cookie names, and so on. All these will give you clues what sort of attack will work. And of course, your main tool is just experience. At first, I remember when I started doing Android apps in depth, at first it seems overwhelming, and then I noticed that there's really only about 5 different kinds of apps. They're all made by basically 5 different tools. Pretty soon I knew the structure of them all. And the same thing's true of websites. All the pen testers and consultants I know say the same thing. At first it seems like there's a lot, and after a while you realize everybody's using the same stuff. It doesn't take long before you become familiar with all the common stuff people are using. So your server-side functionality is here. This one, for example, has a JSP file extension, so it's a Java server page. Then it has order by at the end, which suggests that it's going to use SQL. That's going to be the order by parameter. And is expired is 0, gives you a clue that maybe you could get something expired content by changing that to 1. You could look at the expired version of something, and that might be useful. That's the sort of thinking you put in. Here's another one. You have an ASPX extension, so this is Microsoft. You have a template. This looks to be a file name, newbranch.tpl, so maybe you could change that file name to point somewhere else. This is looking for file inclusion vulnerabilities, which are common in PHP, but anytime where you have a file name as a parameter, you might be able to change that file name. You might even be able to do directory traversal, .. / and get to system files there. There's an edit option. Maybe if this was true, you'd get something else and you'd be able to change files on the server. There's a version number. So maybe changing that would reveal older versions of something that might be vulnerable. That's the sort of thing. Here's a post sending data up to a server. It's a PHP web page it's going to, and this looks like email. There's a message, there's a subject, and so on. You can often use these to send emails from the company like spam. They often don't block that. So you can modify this stuff and send emails from the company. And here's one where you have an action in the URL. Action equals view, so maybe you can make edit or add. And there's an ID number that looks pretty small. This is not a properly random number. It's 117. That probably means if you just try 116, 115, 114, you'll find other good stuff. This happened at colleges. A few years ago, there was a student that just noticed that when you went to view their grades, it just was college.edu view grades and ID equals number. And they just changed the ID and they saw other students' grades because the number was just there and you could guess it. And when they told the college, they tried to expel them and punish them. But, that's the thing. It is a vulnerability. Then there's the difficulty of how do you report it successfully, and that's a matter of social engineering. And so you can often look for consistent behavior. Usually the application reuses code. So if your SQL injections are being filtered out, try injecting elsewhere to see if the filtering is being used everywhere. This, by the way, is what you should do. You should have one authentication server handling all authentication for everything. You shouldn't have rewritten copies of it all over the place because then they won't be all up to date. But that often happens. If an app obfuscates data, see if there's another place where it obfuscates a string. There have been websites where this worked. You were supposed to, it was hiding something important like a password behind obfuscation or encryption, but there's also a place where it hid something unimportant that was under your control, like a username, so you could use that to learn how the obfuscation worked. I did this with Stitcher. Stitcher was an app to play music, I think, online or podcasts or something, and I took the Stitcher app, and I noticed that when I gave it a short password, it sent a short, different word up, and I discovered it was just using the Caesar cipher. It was just moving every letter forward a couple letters in the alphabet, which is pretty appalling. And that was very easy to spot. You could see a clear pattern between the plain text password I fed in and the encrypted data that it created in the app. So error handling is often a place where you find useful information. And I mentioned before Google Dorks. There's a lot of these. This Elma, let's try this one. This one was fun. I don't know if it's still going to work, but It did work at one time. In URL elma.axd. All right. Because this one, Elma, this is a piece of software that I think they run on Windows servers, and Elma is actually the log. In URL elma.axd, okay. There. So this is a database of web errors, and many servers are configured to just serve this up to the whole world. So here's a bunch of people mentioning this vulnerability, and let's see if we can find one that's actually a live Elma. There used to be one of these in Toyota. And again, it looks like this one here. Wow, look at that. Holy crap, that's a bank. That looks like a real winner. That maybe I can't get there. But see, this looks like it's got Elma and it's got a select right there. So this is you can see at the bottom from the URL, this is some kind of injection. And when I go there, it seems to be blocked. So this is some kind of, keyword equals this. Somebody managed to save a page with an attack string in it in Google. I've seen a few, I'm not quite sure how this happens, but it doesn't seem to work anymore. But this was somebody attempting to do like some kind of injection there. Might be some more goodies here. Yep, they get mad when I do this now. System argument exception. That looks pretty interesting. That looks like an Elma error message. And here's another one. Some of these might be interesting. They're a privacy error. Yeah, I understand that. Advanced proceed. Yeah, there we are. Here's an example of an overly informative error message. Now, I've gone here to look at the Elma file and feed in some kind of detail parameter, and now it tells me an error has been thrown, and here it shows me a series of a stack dump of all the functions that were in front, and here it shows me all the server variables. And often these variables include secrets like API keys and passwords and stuff. So this is a bunch of information that should not be publicly available. But something crashed, and the default error message just pumps out all this data I shouldn't know. And this is a similar one with that Elma one. Now let's just see if there's any more fun ones here. 12 apostles, error system HTTP exception. Elma, this is in a foreign language. It might be good, but I can't tell. All right, anyway, there's a few examples there, and in the past I've actually found websites, like I found a Toyota one where it would just show the complete URL of login pages that had errors, and that would include authentication cookies and stuff. Anyway, sort of thing you'll find there with Google Dorks. All right, so look, your app may use a consistent framework of some sort, but look for parts that were bolted on later. It might have some kind of useful encryption or security feature, but there's going to be something added on later, like it was a website, a web server, and they added on the mobile device function later that's imperfectly connected in, or debug functions, or the usage tracking for advertising, things like that. Look for a different appearance of the GUI. Pages that look different, showing they were written at a different time by a different developer. This keeps happening in Microsoft because Microsoft Windows is like the Frankenstein monster. They keep buying companies, and then they sort of imperfectly absorb their code into Windows. So Windows is a patchwork of dozens of different companies, which is why they often have strange security problems that keep coming back. Like Microsoft Office encryption had no random seed, so you could just XOR two Microsoft Word documents that were encrypted, and a whole bunch of it would just turn into plain text. And then they had the same flaw happen again and again over a period of several years because that was a standard practice, and when they bought a new company, that new company would have made the same mistake. This kind of thing tends to happen. Another thing that happens, of course, is client-side validation. You'll see a ton of this in the projects where something important is done on the client side where you can control it. SQL injection, path traversal, cross-site scripting, and so on. Multi-stage login that might have flaws, predictable tokens for the session state, and so on. There's just a lot of things you can do, and it's a long list, but you'll see them in the projects. You'll do them one by one. So I think I'm going to kind of just skip through this. Things like clear text communication, error messages that tell you too much, and known vulnerabilities of code, which, by the way, is a huge one. In my private consulting engagement, they said this is the main one they worry about, is that some of the software they're using is vulnerable. Everybody's become aware of this. That's called a supply chain attack, when somebody poisons some library that you're using, and it's happening over and over, and everybody is pretty worried about it. And there are actually external contractors just to scan your stuff to look for these supply chain vulnerabilities now. I don't know how effective they are. I do know a lot of companies keep getting busted this way. So here's an example. Auth contains authentication functions up here, like forgot password, so you can try to test the session handling up there. Home has the authenticated user content, so you can try to move to a different user by modifying the cookie. And that's nothing too amazing there. Anyway, it's the sort of thing you'd think about to find vulnerabilities in an app. But in the projects we're doing, you're not going to have this complicated an app. We're going to have like one simple attack at a time to get started. So anyway, let's look at the last Kahoot, and then we'll get into the projects. It's 4D, which is here. All right. So like I said, that list of everything seems pretty overwhelming, but when you look at them one by one in the projects, they're much easier to digest. All right, so what extension identifies web server technologies in use? What browser extension, I see. That's Rapalazer, good. All right, what file extension would you find on a LAMP server? This is what open source shops use: Linux, Apache, MySQL, and PHP. So PHP is the one on the list that you'd find there. That's what most of my servers run, because it's all free software. All right, what directory name would you find on an Oracle server? Hit the wrong one. Yeah, it can happen. It's PLS. By the way, Elon Musk is no longer the world's richest man. Larry Ellison is, because Oracle just jumped because they signed a lot of big contracts. Oracle is very proud of their AI cloud services. I hear them advertised everywhere, and apparently people are believing it, and they're moving big AI projects to Oracle. They made like 4 major multi-billion-dollar deals in the last month, and their stock went way up. So Larry Ellison is now the richest man in the world.
Yeah, he's also an early investor in Tesla, though.
What's that?
He's an early investor in Tesla also, so he has a lot of Tesla shares.
Oh, he's in Tesla too?
Yep.
Ah, okay. But I think Oracle is where he's really making his money. Anyway, all right, what token name indicates a Microsoft server? Yep, ASP. Session ID, ASP is Microsoft's Active Server Pages scripting language. All right. Jeffrey. Jason. You'll have to tell me who they are. William. Good. All right. So, we stop this recording.